Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA.
The first two will be two techniques and several tests to show or find conditions on n. By conditions of n is we already know it should go to 0, but essentially we'll see that this will mean how fast n converges to 0. The conditions will be similar to that, such that summation n converges. Okay. So one interesting idea I should tell you, and this should be taken up by Choran sir. So let's take one example where it's simple, it's interesting. Let's say n is equal to 1 minus 1 whole to the power n, like 1 minus 1, 1 minus 1, 1 minus 1. The question is that whether this converges, summation of this converges or not. So this is something called it's really interesting. It's something called Riemann rearrangement theorem. But understand, the partial sums are very different behaving here. Here it's 1, then it will become, this will become, so understand, I'm just writing till this. If you just take this, the first one, it will be 1. If you take the next two ones, it will be 0, then it will again 1, then it will again 0. So it's a 0 1 0 1 sequence, right? So therefore it doesn't converge. So we'll come up with something called, like, there's an interesting thing called Riemann rearrangement theorem and conditionally convergent, that if a sequence is not convergent in but doesn't converge, but summation of mod n converge, then this is not related to this, but then, sorry, I told the opposite thing. This does not converge, but this converges. Then you can rearrange n to get a different sequence, to get any sequence whose sum, so to get, like, you can rearrange n to get a sequence, like n means you change the order of the numbers such that the sum can converge to any number. That's the beautiful part. Then you can rearrange any n to set a sequence such that the sum can converge to any number, any number. Okay. So one such example is 1 minus half plus 1/3 minus 1/4 plus 1/5 minus 1/6. This goes to a finite number. You can prove that. It will done this. I probably this goes to log of 2. But its mod of that summation is 1 plus half, does not converge, right? But this converges. You can show log of 2 probably. So you can rearrange the sequence. Let's say you can do 1 plus third minus half plus 1/5 minus 1/6 plus 1/4 minus 1/4. Okay. You can rearrange this to convert it to, let's say, 2. Anything. Take any number and there is a rearrangement out there which can, this is the Riemann rearrangement theorem, and you will find out here in conditional and absolute convergence. This will be done on Thursday's class. But there's something interesting I really want to tell you. It's fun. So we will teach you two techniques and several tests out there which will find conditions. This is very important. Conditions on n such that a summation of n converges. We understood it must go to 0, but the rate of convergence won't matter. So the rate of convergence also comes into play here, how fast it converges. So in the rest of the class, I will do certain things like something called algebra and list of series. Let's see what is left for me. Telescopic sum, Riemann sum. This is two technique and comparison tests and the Go notation. The things I will teach you now in the rest of the class. Yes, Swati?
So, in the example that you have explained above of minus 1 raised to the power n,
Yeah.
so sir, here the sequence, the sequence does not converge because the partial sums are showing divergent behavior, like 1 0 and 1 0.
Yeah. Also, it doesn't convert to 0. So hence also it doesn't, the series must not converge. Yeah.
So, but
This
it
sequence converges to 0. It doesn't converge to 0. Hence its series will not also converge.
okay.
Okay, all of you understood till this point of time, guys? Yes, no? Please give a thumbs up if you have, okay, and ask doubts. Okay. Now the rest is algebra of list, algebra of sequence and list. It's essentially the same thing. That if there is a series that converges, then constant time that series, if you add a, let's say, sequence whose series converges, then the summation of constant times that sequence will also converge. If there are two sequences an and bn which converges, then summation of an plus bn plus minus bn will converge also. So summation is a linear operator. So it's like it can take any linear linear. I think that's it. Anything else? Yeah, that's it. An plus a constant will not converge because that therefore an plus constant, that sequence will go to that constant c, which is non-zero. Hence it will not converge, because for the series to converge, everything must go to 0. So yeah, that's it. Observe that this is, if an and the bn converges, an plus bn plus minus bn also go to 0, and root c an also goes to 0. So there are other results too. Those are given as problems, but this is a basic algebra. And also you need to know the list. Certain lists you need to know. So make a list of series you can find online. But one thing that is, you will see that we will learn later on is Taylor series. We'll learn later on that, let's say, just give me a minute. Let's say sine x is equal to, you can there's certain, for example, there's certain Taylor series out there. For example, e to the power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial dot dot dot. Log x is equal to 1, log x plus 1 is equal to 1 plus x by 1 plus x by 2 plus x square by 2 plus x square by 3, and dot, dot, dot. You can see from here, if you put 1 here, okay, I mean, just check this series, this Taylor series. Maybe I've done some errors out here. Just check. It can be minus also, like this. Sure. Oh, okay. Yeah. Thank you for letting me know this. Yeah. Yeah, I forget these things. X minus x squared by 2 plus x cubed by 3 minus x to the power 4 by 4 dot, dot, dot. So you can observe that if you put 1 here, it will be 1 minus of plus 1 1 third. So you can observe that if you put it here, it will go to log of 2. And there are other things also, okay? Cos x, sin x, and this thing. You should remember these things, and you should make a list of all these things. This is called Taylor series, and you will learn it in depth what it means and stuff. But there's certain expansions you should know for which helps you in such series thing. And you can add this and play around with this. These are like a basic list and basic arsenal of tools you should have, just like you did in sequences, okay? So that you can identify quickly these, and you will see why it. Okay, this is the basic thing I need to do this now. And okay, so now let's go to telescopic sum. This is a basic thing. I'm not asking you whether you understood or not. This was basic fact. Telescopic sum. So understand, telescopic sum means this very fundamental thing that, just give me a minute, guys. So what is telescopic sum? Telescopic sum is this, that, so let's do an example. Let's say summation of k from 1 to infinity 1 by root over k plus root over k plus 1. Okay. So you can understand that probably here I can see that it goes, it's of twice of root over n. We know some root over 1, like 1 by n goes to 0, but root over 1 by, like root over n probably will be converging less fast. So if you see, root over 1 by n will be like this. So probably diverge, but the basic idea of telescopic sum is this, that you can observe that this is turns out to be, if you rationalize it, it will be root over k plus 1 minus root over k. And what is this? If you observe, it's nothing but root 2 minus root 1 plus root 3 minus root 2 plus root 4 minus root 3, and it can cancels out. And you will see at the nth, the summation of k from 1 to n root over k plus 1 minus k is nothing but root over n plus 1 minus n, and you can observe that this goes to infinity. So this cancelling out term, by cancelling out, you can go telescopic distance. This is called the telescopic sum. Okay. And in fact, understand there is an inherent telescopic sum inside every sequence. Every sequence can be expressed as a telescopic series. Every sequence. How? Let's take an. So you can see an to be a1 plus a2. Let's observe this. A1 is a1, but a2 is equal to a2 minus a1 plus a1. The a3 is equal to a3 minus a2 plus a2 minus a3, a1 plus a1. A4 is equal to a4 minus a3 plus a3 minus a2 plus a2 minus a1 plus a1. So observe that any an can be represented as summation of, so let's define another term. So understand that it's nothing but a1 plus summation of, so you can represent a1 as a1 minus a0. So define another term that called a1 is equal to a0 is equal to 0. So you can observe that a1 minus a0 can be equal to a1, just like for sanity. So you can observe it's nothing but summation of ak minus 1 from k from 1 to n. This is nothing but an. And you can see there's nothing a telescopic sum. So observe that often you can represent this. For example, you can represent this sequence as this telescopic sequence. If this is an, this is ak minus 1, or ak plus 1 minus ak. You can observe this. So therefore, every sequence can be represented a telescopic series, and this is fun. You will see that this is coming up again and again. while solving problems. So the first question that you should ask yourself, that can I represent with a telescopic sum, because it's easiest thing, you can understand it. Okay, let me give you another example. Let's say summation of k from 1 to infinity log of k plus 1 by k. You can observe this is nothing but summation of k from 1 to infinity log of k plus 1 minus log of k. Another interesting example is summation of k from 1 to infinity 1 by n square minus 4n plus 3. You can observe this is nothing but, you can observe that summation it's k from 1 to infinity 1 by n plus, so you can observe it's nothing but n minus 3 into n minus 1. So it's half times, okay, so let me do it here. It's 2, so it's n plus 3 minus, so n minus 1 minus n minus 3 by n minus 1 times n minus 1, n minus 3, and it should be half. Observe, because this is 2. So this is nothing but summation of n minus this half times 1 by n minus 3 minus 1 by n minus 1, n from 4 to infinity. So you can observe this is nothing but, you can write it as half times 1 by n times 4, 1 by 1 minus 1 by 3. The next one will be 1 by 2 minus, for n equal to 5, 1 by 2 minus 1 by 4. Then n equal to 6 scale, it will be 1 by 3 minus 1 by 5. Observe this 1 by 3 cancels. And then again, next one, 1 by, for n equal to 7 scale, it will be, or 6 scale, 1 by 3. For n equal to 7, it will be 1 by 4 minus 1 by 6. Observe this 1 by 4, 1 by 4 cancels. Okay. And you will again see that for the next one, it will be 1 by 5 minus 1 by 7. So this 1 by 5, 1 by 5 will cancel. And the last term will go to 0. And therefore, the telescopic sum will go to half into 1 minus 1 plus half. So it's, you can see everything gets cancelled after this point. This will get cancelled in the future. And therefore, it will be 3 by 2. So it's 3 by 4.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.